And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and we're looking at a tale of two coronal mass ejections, two radio bursts, a bunch of solar flares, 3 in the C-class range, electron flux, major earthquakes, lots of stuff happening. Let's get to it. Great view of two coronal mass ejections from the Solar Dynamics Observatory here in 304 angstroms, ionized helium. And here is a colorized magnetogram along with 171 angstroms, ionized iron. And we've got a bunch of missing data here, so we've had to put together some pieces of the puzzle here for you. We'll get to that in a moment as well. First, the northeastern limb. Another active region rising right over here under my pointer. And newsflash, it is a sunspot. We already saw umbra when we did show prep, so tons of stuff going on. Let's blast through a whole ton of data. First, a 193 angstroms view. Fantastic close-up of sunspot 2824 and the new sunspot 2825. It will get a name today. And we'll show you the most recent high-resolution imagery of that. Next, let's take a look at the viewpoint from Lagrangian point 1 on the Discover. It's the SOHO-LASCO C2, and you can see one of the coronal mass ejections is off to the northwest. So one expected to miss the Earth. And if I had to guess, and I don't, so there's that one. You can see that bubble going off to the northwest. But we also see ejecta coming out over here. And so one of those two coronal mass ejections likely does have an Earth-facing component. We'll have to crunch more data on that later in the day. Hopefully that will become available. Here's a full disk view back to 171 angstroms here. Back to the SDO. And again, the LASCO SOHO Discover spacecraft is at Lagrangian point 1, about 1 million miles toward the sun, in between the sun and the Earth. Lagrangian points are gravitational equilibrium points where an object can remain orbiting along with the Earth with minimal use of fuel. So a bit of activity happening here. Quite a bit of activity happening here, both in space and on Earth. Mainly in China. It's a cheap Chinese plastic earthquake. We'll talk about it in a moment. First, a diagram of the solar system. Here's where things are now. And we've advanced that 1 week for your forecasting pleasure. By the way, it's only 29 days and 17 hours until the solstice. Do you have any special plans for the longest day, or if you're in the southern hemisphere, the shortest day of the year? Here's a star chart. I like to draw in the ecliptic and face my star chart to the south. I'm currently facing the south. If you want to make your own, like mine, in-the-sky.org, just put in your zip code, city, or whatever, and you can build a star chart. You can even advance the star chart by bringing down the sidebar here. And you can animate it. Good times. The sun outputs a bunch of radio signals, and one of them is a very consistent one in 2,800 megahertz, otherwise known as the 10.7 centimeter radio flux. It emanates from the upper chromosphere and lower corona. Current 10.7 centimeter radio flux is at 74 solar flux units. Here's a 1-year chart of that to put it in context. As cycle 25 sputters on, the black line here is the radio flux, the red line is the sunspot number, and you can see how proportional they are. Don't be surprised to see a precipitous increase in the radio flux in the coming days. We're not seeing any forecasts for any geomagnetic storms here on the Space Weather Enthusiast dashboard. That's the Noaa Forecast for space weather. And sometimes that forecast differs from my forecast. you have to have checks and balances on these things. And check it out, we saw an end to the 7 magnitude earthquake drought. So we saw a 7.4 magnitude earthquake happen in China on the eastern Tibetan plateau. So that cheap Chinese plastic earthquake right there, the cheap earthquake from China. If that would have been in the U.S., it would have been like a magnitude 9 earthquake, okay? Anyway, there's the location of that. 7.4 magnitude. Initially reported, downgraded to a 7.3. And we're showing you 6 magnitude quakes here as well. Excuse me. We also saw 2 6 magnitude quakes, one south of the 7 and one in Oceania. Let's scroll up the list. And if we miss anything, just let us know in the comments. Japan saw a deep quake at a 4.3 magnitude. Sumber Pokong, Indonesia, saw a 5.7 at just over 100 kilometers depth. There was a 6.1 magnitude foreshock in China. It was south of the major quake, though. I guess not really a foreshock. Too far south there. Probably like 800 miles south. And China's a pretty big country, folks. So here we go. Here's this 7.3 that happened at 1804. Thanks to Mary Wright for informing me of that earthquake yesterday. Thanks for dropping me a line in that. Here's an interesting quake indeed. This one occurring at 10 kilometers above sea level. Let's check the location of that one just for fun. And that one occurring at 1 kilometer up in the air, according to the data. And we've actually covered in previous videos why that happens. I won't mention it today. You'll have to watch the rest of our videos, I guess. Also, a 6.5 magnitude quake happened here at south-southeast of Alo, Wallace, and Futuna. Oceania, the deep quake capital of the world. It was a 6.5 magnitude, the second largest quake of the past 24 hours, so a big uptick in earthquakes there. Seismicity now considered very high, following that lengthy 60-day lull in 7 magnitude earthquakes. So a bunch of aftershocks happening there in China. Also a deep quake at Nicaragua, 4.2 at 155 kilometers depth. Also Vanuatu saw a nearly 200 kilometer depth 4.6 magnitude quake. And let's check volcanoes. Suwanosejima in the Ryukyu Islands has been exploding and producing a 4,000-foot ash plume. Luotolo in the Lesser Sunda Islands, 7,000-foot ash plume there. Semeru on East Java, 14,000-foot ash plume above it as it explodes. Nevado del Ruiz in Colombia, now back on the list, exploding, 19,000-foot ash plume. Sangay exploding, 24,000-foot ash plume over Ecuador. Sangay in Peru exploding, 27,000-foot ash plume. And we're unable to detect the Nevados de Chileans eruptive status. Please do not pole vault the caldera. This public service message brought to you at Massive Personal Risk and Expense by smashamash.com. Don't forget to visit our websites. smashamash.org will redirect you. And check it out. We saw a C-class solar flare as we did show prep today. So that would make 4 C-class solar flares here over the past 24 hours. Major uptick there in solar flaring activity. That data from the GOES X-ray flux. That's the GOES 16, by the way. No strikes on the proton flux here, and not really expecting any there either. Although if we do see a coronal mass ejection strike, well, we're not expecting a spike in the proton flux, period. Because the coronal mass ejection, if it is going to strike the Earth geospace, we're expecting it to be more of a glancing blow. We did see ejecta on the far side of the sun also, which can make it very deceptive. The GOES magnetometer over the past 3 days, fairly smooth here as Earth is now in a North Pole-oriented current sheet. We've also seen the coronal hole wind stream subside a little bit. And let's take a look at the current sheet. Here you can see the Earth currently in the green portion, the North Pole-oriented current sheet, South Pole current sheet shown in red. Keep in mind the data is 1 hour and 13 minutes old by the time we made the video. Here's the latest image. Here's a line of sight ecliptic plane field plot. A more earthly view of the same data. And you can see some significant fields associated with that sunspot 2824. Next, a line of sight coronal hole plot, which shows the sun's B field in blue. The blue potential field surface source lines there are the sun's B field, which is taking its good old time performing its solar polar field reversal process. And next, we're looking at sunspot groups and filaments. There are still filaments in between Earth and Sun, folks. We could see additional coronal mass ejections. Don't be surprised to see us make another video about that later in the day. And again, sunspot 2824. Surprisingly not, I don't know. I think it's downgraded personally. I think it's an alpha class. But again, there's another active region rising here, and that is a sunspot. That'll be 2825. It will get a name today. The KP index, a measurement of global geomagnetism currently at 2. And now the real-time solar wind. And again, you can see the coronal hole wind stream subsiding here. Current solar wind speed, about 447 kilometers per second. Solar wind density quite low here, 3.46 protons per cubic centimeter. Otherwise, pretty uneventful on the real-time solar wind data. Let's look at 4 hours of data for the geospace. It's a 4-hour geospace magnetosphere movie, courtesy University of Michigan. And we're not surprisingly seeing a fairly steady magnetohydrodynamic pressure here, as modeled by the space weather modeling framework in nanopascals. Most of the pressure here on the magnetotail, non-sun-facing side of the geospace. How about delta B geospace data here? Here's the nanotesla space weather modeling framework data for ground magnetic perturbations. We show this daily as well, since we are currently living a geomagnetic excursion. And we see blobs of magnetic change here quite close to the south geomagnetic pole, which is somewhere south of Australia. I'm going to let that play through a second time, as there are some slightly anomalous features here on the ground magnetic perturbations map. You'll see a pulse coming out of the central Pacific Ocean right there. And some minor perturbations over the Siberian and Canadian North Poles, as well as the South Geomagnetic Pole. Next, I'd like to thank our viewers, all of them, wherever you're viewing from. And we'd like to also thank Twitch for tuning in. Thanks to our new Twitch followers, etc. Or to quote Eugene Bagashov, etc., etc. If you're not viewing the content on YouTube, youtube.com/smashamash. Most of our content is there. If you're viewing any place besides YouTube exclusively, you're probably missing about 60% of our content, maybe even 70 or 80%. We love the Twitch platform. It's a fantastic live streaming platform. It's good enough for gamers. It's probably good enough for you too. Twitch.tv/smashamash. We're also on BitChute, regularly putting exclusive content there. Next, thanks to our patrons, the true source of funding for the content. If you'd like the earliest alerts and all kinds of analysis, science, data, multimedia, etc., consider becoming a patron at patreon.com/smashamash. We need your assistance to continue rolling back benefits to our patrons. So help fund us so we can help expanding our operation. Also visit our own website, smashamash.com. Smashamash.org will redirect you. Today's featured product can be found on the smAsho merch link right there. And it's our Do Not Pole Vault the Caldera tote bag. So thanks everybody who's been picking up merch. The Do Not Pole Vault the Caldera tote bag is available in 2 different formats. One has this polyester shell and this smaller print. By the way, the print quality is quite high on all of these products. And also the Do Not Pole Vault the Caldera cotton tote bag, a little bit of a different design. The very large design on this one, more fashion-y on this one. And again, you can find all of those links on the homepage, smashamash.com. Smashamash.org will redirect you to that homepage And let's do today's cosmology segment. Today's cosmology segment brought to you by me at massive personal risk and expense. Today we're not going to pick a random number at all. We're going to take a look at the Virgo Cluster. Yes, the Virgo Cluster. That's NASA's astronomy picture of the day. You can find it yourself at apod.nasa.gov. apod.nasa.gov. It's a string of galaxies, and it's a massive string of galaxies. And it is gravitationally interacting with the local cluster, the one in which you live, consisting of galaxies such as M31, the Andromeda Galaxy, and the Milky Way. And this one contains massive lenticular galaxies, M84 and M86, as well as NGC 4438 and 4435, which are interacting galaxies. NASA's apod.nasa.gov, NASA's astronomy picture of the day, is the Virgo Cluster. Let's talk about the morphology and the 3D modeling of supernoval remnant IC 443. Here it is in red light on Aladdin light. And if you zoom in, it's a very interesting supernoval remnant. It has a pulsar wind nebula inside of it. And you're looking at here the red spectrum of optical light. And that is the pulsar wind nebula there. That is where the center of the crosshair is located. If you look at it on the 2MASS, it's very different in terms of its heat output. And you can see hotter areas here in blue, cooler areas in red. That's the 2MASS. And if you zoom way in, that's the location of the pulsar. We'll also show you this on Chandra. So there's that supernoval remnant in X-ray. And you can see it's quite a significant X-ray emitting region. It even shows up in gamma on the Fermi. That supernoval remnant upright gamma spot. It's IC 443. And you can find this great article here on phys.org. Phys.org in the Astronomy and Space section, a 3D model of this supernova and its pulsar wind nebula. An absolutely fantastic animation. We'll show you a little clip of it. Again, it's on phys.org in the Astronomy and Space section, this article. I'll play a little clip. Check it out. Just fantastic. So a whole lot of data sets there combined to get these 3D models. And you're looking at all kinds of different spectra here. It is a molecular cloud, so there's different chemical signatures showing up in there. I won't get super in-depth into it. We don't want today's cosmology segment to be too long because there's too much other space and Earth weather to be covering. And we've scrolled the article there for your convenience. And that's today's cosmology segment. Thanks for tuning in. We'll have to say goodbye to Twitch. We'll bring you back for the meteorology segment, which once again is kind of interesting. Let's continue on with the daily space weather. Here at the Smash News Network, least busted name in news. The next thing we're going to cover is Earth's Van Allen belts. Here's a diagram of them. There are electrons out there. Let's take a look at those. Sometimes those electrons can charge up satellites. And we're surprisingly not seeing any charging hazards yet. We're expecting some to come soon. And here's a one-year chart of the electron flux, and you can see that sudden increase in the electron flux there, something that we regularly see following a coronal hole wind stream as plasma travels like train cars in space, with the connections being the electron flux. So here's the increase. I'm forecasting the electron flux to reach warning levels today at 1,000 pulse flux units, which is also 1,000 particles per negative squared centimeter there. Anyway, that's the 3-day chart of the electron flux. Again, expect to see warning levels today. We may see some communications problems as well once we reach warning levels, and we are expecting warning levels Noaa agrees. Here's the forecast. The green box there is the forecast. The yellow diamond is the observation. And here's the total electron content forecast visualization. It's showing you the whole error column and the likelihood of GPS errors. The redder the blobs of electrons are, the more likely you are to see an electron flux-induced GPS error. Here's another diagram of the atmosphere showing you the F ionosphere layer, which is this red F right over here. Not to be confused with a salamander known as a red F'd. Don't be F'd. Know what's going on in the F layer. Here is the F layer. It's an ionogram for the past 48 hours. And it's showing you 2 hours per each second here. So no major anomalies, at least yet, showing up here. Everything looking pretty normal there in the ionosphere. And leave us a comment if you're seeing something I'm not. Anyway, here's the latest image coming in at 9:45 Universal Time. And it's time to talk meteorology. So welcome back, Twitch. We've got some serious cold anomalies here west of the Rockies. And we've got some serious hot anomalies east of the Rockies. A major demarcation line has formed. It is the Rocky Mountains. And it is really cold in the western portion of the U.S., and quite hot in places like New York, Pennsylvania, and New Jersey. That's the 2-meter temperature anomaly there from Tropical Tidbits. And we'll advance this into the Gfs forecast here for a couple of days. There's where we expect things to be tomorrow. The northeast will remain hot, and the west will remain quite cold, although some turbulent temperatures there in places like Wyoming and Colorado. Anomalies on both sides. Texas expected to see some temperatures here 12 degrees Celsius below normal. The western U.S. is going to remain very cold here. That's the forecast for, let's move this ahead one more notch here. There's the forecast for 6 o'clock Universal Time on Tuesday, May 25th. The temperature anomaly GFS forecast from Tropical Tidbits. Next, we'll look at the jet streams of the eastern world. There are the jet streams of the eastern world. Jet streams blowing backwards across the Indian Ocean once again. How about the surface winds? There are the surface wind scenarios. A powerful system there northeast of New Zealand, rotating clockwise. Low pressure systems rotate clockwise in the southern hemisphere, folks. Here is the western world's surface wind scenario. We've got a south to north wind here blowing across Texas and indeed Oklahoma. Here is the 250 hectopascals. The 250 hectopascal pressure winds here, otherwise known as the jet streams. And look at the extreme meridional jet stream bends here over the Atlantic Ocean. A 180-degree bend there over only a few hundred miles. And quite strong jet streams there, blowing both due south and due north. Almost due south and due north. It's extreme meridional jet stream flow at its finest. Next, we're going to take a look at a real-time lightning map. I like to use lightningmaps.org when I hear thunder. It tells me where the most intense parts of the thunderstorm are located, and if I should get inside or seek shelter immediately. Lightningmaps.org. It's how you convince the natives that you're Thor, or perhaps Odin. Here's the NASA GOES lightning mapper. We did see some lightning here over South and North Dakota, a little bit over Colorado, Wyoming, Utah, Nevada, and Idaho. Some over the Gulf of Mexico, and continued lightning here over southern Mexico. Next, check it out. We've got a snow cam here. It's snowing in Nevada. And one of the benefits of windy.com is that they've got these great webcams. Check out all the snow. Oh my God, it's so hot that it's cold, folks. Make sure that you don't burn any tires today and reduce your CO2 output, because mankind has made the planet so hot, folks, that it's cold, which has, by the way, been a real story. Oh my God, New Zealand is going to melt. Greenland is going to melt. Look at this. Oh no, there's only more than 5 meters of snow in that portion of Greenland. Greenland is going to melt, and you could have ocean water lapping at the front door of Barack Obama's home at any time, folks, because Greenland is going to melt. It's only got 5 meters of snow nearly from coast to coast. Here's the U.S. Doppler Radar Map. As snow continues to fall in California, Oregon, Idaho, Utah, Wyoming, Colorado, and Montana. It's nearly June and it's still snowing, folks. How about ever heard of a year without a summer? By the way, there are also frost advisories in Northern California. In fact, I think it's a freeze warning. I won't even go back and look. Here's what's going on in the cloud layer. Powerful low pressure system here just north of Bermuda. A counterclockwise rotating system. And some massive pressure gradients there. This dry air is going to weaken the system. This dry air right here is not helping things, although it is butting up against that. So if we get some hot temperatures there, we could see that system intensify. In any case, again, there's the U.S. Doppler Radar Map. Look at this snow down here, all the way in the southern portion of California there, way down south, currently showing snow on the Doppler radar. Again, there's the cloud layer. It's too dark to see the clouds. We use a 3.9 nanometer NASA GOES interactive weather satellite to determine where clouds are at nighttime. Again, there's the water vapor map. And that's today's meteorology segment. Thanks for tuning in, Twitch. And we've gotten rid of Twitch for our bonus features. Here come the daily space weather bonus features at the Smash News Network, least busted name in news. How about some ground-based observatories? Well, this data from El Teide, Spain is only 7 minutes old. Here's the latest hydrogen alpha imagery from there. And again, I would note, folks, there are still major filaments all around here and down here. So the possibility for additional coronal mass ejections in the Earth-facing region are still there. Don't be surprised to see additional ejecta and possibly an additional video from us today. So here's what we saw when we did show prep. And there you can see Sunspot 2825. There are the fields. There's the umbra. You can clearly see a dark spot there. That's Sunspot 2825. And let's get the latest imagery here. Sunspot 2824 still does have some surrounding umbrae there. So it could still be active, folks. I'd say it probably still is, as we saw a C-class flare as we did the video. And here's an extreme close-up of the northeastern limb. You can see at least 2 of the solar flares in there. So likelihood for additional activity is still there, folks. And this is a composite here. Now we're showing the 131 and 94 angstroms wavelength from the Solar Dynamics Observatory. These take more images per minute than the rest of the wavelengths. So we combine this in a faded composite image. In any case, thanks again for tuning in to the Daily Space Weather. Look for at least one more video coming from us later today, and may that solar wind be at your back.